So I'm Farrell, founder of PerlTricks.com, and I'm on Twitter under @PerlTricks, and I regularly tweet about Perl stuff, articles, community news, and open source stuff. So if you're on Twitter and you don't follow me, feel free to follow. I just wanted to make a quick announcement too. I brought a bunch of vinyl onion stickers, and they're available at the registration desk. And last time I checked, there were loads of them left, so pick those up while they're still available. But today I want to talk about testing application axioms. And I want to clarify that this isn't the test axioms paper by Paul Gerard. That's more about the philosophy of unit testing itself. I'm going to be talking about something a bit more pragmatic than that. So what do I mean by axiom? Well, Wikipedia says it's a premise or starting point for reasoning. And I've defined an application axiom as an unchanging fact about the application. So an example might be the code must compile, because if your code doesn't compile, you don't have an application, you just have some text that aspires to be an application. So that would be a fact about an application. And what do I mean by testing? I'm talking about the computer programs that we run to check that the code is correct. We often automate them as part of a release process, and in Perl we put those under the T directory, and sometimes the XT directory too. So here's a basic Perl test script. You're probably all familiar with this. I've got the shebang line at the top. I import test more. Within a begin block, I import my app, which is the sample module I want to test. And that's important that that's within a begin block if the module exports symbols that I want to be available to the rest of the test script. And then the line below that, I call the OK function and test creating a new myApp object. And if it returns true, it passes. If it returns false, it fails. And then done testing wraps up the line. So this is a kind of very typical example you'll see. But it rarely stops there. We want to add more tests normally because we want to test an API. So in this case, I've added some sample tests to create an order and set some types and things like that. And you can imagine this test script would have many, many more tests in it. So what we're really doing is testing the API of the code. And best practice says we want 100% test coverage. We test every method. We also need to account for cyclomatic complexity. So if there is control flow within a method, say it has an if statement that says, oh, if X is true, do this, else do that. We'd want to write at least two tests, one where X is true and one where X is false. And then you have techniques like boundary value analysis, where you want to pass a whole range of values to check that the code behaves correctly under unusual circumstances. So for even a simple API, this leads to hundreds of tests. And that is fine, but when your API changes, your tests need to change as well. And so that can get quite expensive. So one way of dealing with this that Jeffrey Thalhammer told me is he writes tests when they're cheap enough. So what he meant by that was at the beginning of a project, an API is very fluid, you're prototyping, you're getting a feel for the problem space, but at some point in your project, the code becomes a lot more stable, and at that point, he writes tests, because he's not going to have to rewrite them as much. So that's one way of dealing with that cost of maintaining API tests. This is a quote from Jeff Bezos and how he thinks about change. And basically he's saying he often gets asked what's going to change, but very rarely gets asked what's not going to change. And he thinks that's a more valuable question. Well, what doesn't change? Application axioms don't change. And I know that because I put it in the definition. Yeah. So we already write axiomatic tests today, or we have them available, and the quality style tests are axiomatic. You know, things like checking that you've set a version variable, and all the dependencies used in the project are in your make file, and the pod is correctly formatted. Those are all axiomatic. And the test quality module has a complete list of those checks. So I think it's worth thinking about how useful tests are versus how expensive they are to maintain. And so I've got this graph with cost of maintenance is on the y-axis and usefulness is on the x. And this isn't to scale, this is just an arbitrary indicator. So I would put quality tests somewhere about there. So the cost of maintenance is almost zero. Once you've configured them for your project, if they need configuration at all, they'll always be valid. And I've also said they're not very useful because if your quality tests fail, you know you have a problem with your application. But if they pass, you don't know that your application works. And I put API tests up there because whilst they have a high cost of maintenance, because they're so tightly bound to your actual code, if you have good coverage and your API tests pass, you could have high confidence that your application works. And as Jeffrey pointed out, the cost of maintaining API tests probably comes down over time as your code matures. So what I'm interested in is this space here, where perhaps we could have more useful tests, but they have a zero maintenance cost. So more useful axiomatic tests. And there's probably a few examples that you might be familiar with. So code compilation, right? You could have a script that recurses through lib and tries to compile every Perl module it finds. File permissions. You know, if you have tests in T directory, they should be executable, that kind of thing. Data correctness. So if you have YAML or JSON configuration files or external files, you can run tests to check they're formatted correctly and so on. And you can use Perl Critic to review your code as well. So all of these kind of refer to an external standard that you can say this applies to my project, and we can write a generic test to use that standard, which is not specific to your application code. So here's an example of a code compilation test. It starts with the shebang line and import test more and path tiny. Path tiny is a file manipulation module. It's really useful. And then I create a path tiny object on lib and set up an iterator to recurse through lib. I then use a while loop to pull out each path out of the iterator and skip ahead if it's not a file and it's not a Perl module file. And then the test fails if it fails to require the file. So that's completely generic, and for most Perl projects you could write something like this and it would always work. So a more unusual axiomatic test might be something like this, which is an example for Catalyst. So if you had a web application and you had a /admin path and all your functions were under that path, they did things like creating a user, setting passwords, the sorts of things that you only want authenticated users to be able to do. You could this script will test that. So it uses a plugin called Catalyst Plugin Action Paths to extract all of the URLs supported by the Catalyst application. And at that point, it loops through those paths. It tries to fetch if it's an admin path, and if it succeeds, it throws a failure because it's not authenticated. So like the compilation test, we really start with some data, we create an iterator, and we have a generic test to apply to every item in that data. So here are some other types of axiomatic web application tests you could write. You could do things like check all public paths return 200, that you don't have any stale links. These things are still generic, but they're more useful in the sense that if you have a web application, most of these things should always be true, or you'd want them to be true, depending on the type of application you've written. So coming back to this graph of usefulness versus cost of maintenance, I would say that those types of axiomatic tests are more useful because they're getting you closer to checking that your application does what you want it to do, but they still have an almost zero cost of maintenance because they're completely generic. Okay, so I've got a multi-step method to help you identify and write axiomatic tests for your application. And I'm giving this away for free, folks, so pay attention. First thing you want to do is reason about what attributes of the application are unlikely to change. Right? And then the second thing to do is to write a non-specific test for that attribute. And so you have your data, an iterator, and some kind of test. And that's it. It's really simple. And that's all I got. So thank you very much.